Okay, let's take a look at using substitution to find definite integrals. So this is coming from section 6.5. The homework assignment is 21, and we'll start with the first question here. This may seem like a brand new process, but it's really not. This is things that we've been doing since we started doing integration. It's things that you've done a couple homeworks ago with this, these finding definite integrals. And then there's just kind of one extra step tossed in. So once you know how the steps work, it's really not that bad. So let's tackle this first like we would any other substitution question. So if we had to use substitution, we want to be able to rewrite this integral in a way that we can handle it. I can't handle this integral. I don't have rules. None of my integration rules work for this. So what do I need to do? I need to rewrite it. I could do the integral of u to the third du, right? You know how to integrate u to the third. And I've got something here to the third power. If I can take care of everything else in this particular integral with this du, then I'm all set. So let's see what happens. We've said u to the third, so that makes our u what's inside the parentheses. I don't know how you want to do this. I usually do a box off to the side to get my du, but I start with u equals x squared minus 1. Then the derivative of u with respect to x is going to be 2x. And so that means that my du equals 2x dx. So let's compare that to what we've got up here. I have a du here, a du here. So these should be the same thing when we look at it in this problem. Got dx, that's true. And up here, I've got an x, but down here, I have two x's. I have twice as much as I actually need in my du. So I'm going to have to multiply the entire integral times a half. I'm just dividing by 2 because I have 2 times what I actually need here. And if you can't remember the logic behind it, if you set them up the way that I do, if you have anything extra here, it goes into the bottom of a fraction in front of your integral. If you had anything extra up here, it would go into the top of the fraction. Here, we don't have anything extra. It's just 1 times whatever's here. The 1 is basically that 1 from up there. But like I said, if you have something extra here, it goes into the bottom. Something extra here goes into the top. And now, the big thing that's different from when we did substitution before is we're taking a definite integral. They're giving us this bound to evaluate over. They're telling us from 0 to 2. But that 0 to 2 was from x being 0 and x being 2. And we got rid of all of our x's. Right now, all we have here are u's. So we need to change those bounds to u bounds. And to change the bounds, so we'll do the u upper and u lower. All we have to do is plug these numbers into what we found was our u. So here I've got a 2 for my upper bound, so I'm going to plug a 2 in here. That's going to give me 2 squared minus 1 equals 3. And for my lower bound, that's going to give me a 0 squared minus 1 equals negative 1. Okay? So once you get to this point where you've got everything else set up, plug in whatever your bounds were into what you found for u, and that's going to give you your new bound. So my upper bound is 3, my lower bound is negative 1, and now I'm just going to plug in those values for u, because we got rid of all of the x's. If I plug in those values for u once I've solved it, we're going to be all set. So let's take our find our integral. That's 1/2. The integral of u to the third is going to be u to the fourth over 4, and we're evaluating that, we're multiplying these times each other, from negative 1 to 3. So that's going to give us u to the fourth over 8, right? What I did is I just multiplied those times each other, and so that's going to be u to the fourth minus 8, forgetting my equal signs here, from negative 1 to 3. So that's 3 to the fourth over 8 minus negative 1 to the fourth over 8. Make sure you put that negative 1 in parentheses. If you don't put that negative 1 in parentheses, you're going to wind up with an extra negative here that you don't want. We want negative 1 to the fourth. If we do just 1 to the 4th and then take the negative of that, it's not going to be the answer we're looking for. So here we have 3 to the 4th, which is 81 over 8, minus negative 1 to the 4th, which is 1 over 8. 81 minus 1 is 80 over 8, which gives us our answer of 10. Okay? I'm going to recommend that instead of rewatching this to figure it out, to maybe watch a couple more of these and watch me work the same thing for a couple of the other homework questions. And if it doesn't make sense to you after you've seen it for 2 or 3 of them, then come back and try and rewatch. But I think the more times you see me do this with different questions, the more it's going to sink in exactly what I'm doing. So I'll walk through this one more time, because there were a few things that happened here that we haven't seen before. We started with a function that we really didn't know how to integrate, so we rewrote it as u to the 3rd du, because we had something here that could be u, and it's raised to the 3rd power. So we did what we did before for substitution. We took our u, found the derivative of u, and then found out what our du was. Our du was 2x dx, but what we had in our original function was just x dx. So we had 2 times as much as we needed, so we had to multiply our function, our integral, by a half. Then we had to find our new bounds, because this is in terms of u and not in terms of x. You have to take the upper limit from your original integral and plug it into what you found for u, and that's going to give you your upper u bound. So I plugged in a 2, that gave me 4 minus 1 equals 3, and that became my new bound. For the lower, same thing. Plug the 0 into where the u, what you found for u. That's going to give you u squared minus 1. 0 squared minus 1 is negative 1, and that's your new lower bound. And now you find your integral and evaluate over the new u bounds that you found. You don't have to plug in anything else for u. Don't go back and plug in this x squared minus 1 like we did before. We've reset the entire problem in terms of u, so we'll just keep working it in terms of u. And so we were able to figure out that our integral was u to the 4th over 4, but because we had to multiply by the 1/2, we wound up with u to the 4th over 8. Plug in our values, make sure to use good parentheses, do the algebra, and you should end up with the correct answer. So that's your first look at definite integrals using substitution. But I will do some more of these because all the repetition should help you figure this out.